Hello everyone, welcome to Module 6. In this module, I will review our discussion in Module 5, and then we will focus on the statistical storytelling in this module. And at the end of this video, we will apply the t-test statistic for the COVID-19 data in the US counties. And also, 3 assignments are designed in this module. The first one is the short quiz about reviewing the concepts of statistical literacy and storytelling. The second one is the discussion about statistical storytelling. The third one is a comparison of COVID-19 daily infection rate using Microsoft Excel. In our previous discussion, we focused on the t-test as a method of hypothesis testing. I mentioned that the hypothesis can be designed to form. The first one is the null hypothesis. The second one is the alternative hypothesis. In the null hypothesis, we emphasize on the no differences or no effects between 2 data sets or 2 variables. Conversely, in the alternative hypothesis, we emphasize on the differences between 2 groups or 2 data sets. And also, hypothesis can be defined 2-tailed or 1-tailed. If we stated bigger than or less than or positive or negative statement in the hypothesis, our hypothesis is a 1-tailed. Regardless of the type of relationship between data sets, our null hypothesis is a 2-tailed. And by applying the t-test statistic, we need to find the probability value or p-value. If our p-value is lower than the certain amount, we can decide the significant relationship. If our p-value is the area under t-distribution curve. In the null hypothesis, we assume that there is no differences, or we assume the equal mean between population and sample. Against the null hypothesis, we assume that our population mean is bigger than the sample mean, or population mean is smaller than the sample mean, 1-tailed alternative hypothesis. If we don't emphasize on the type of relationship, regardless of the bigger or lower, but we emphasize on the differences solely, our alternative hypothesis is 2-tailed. So it is important that in the hypothesis formation, we can design the 2-tailed or 1-tailed, but the important item is that we emphasize on the no differences in the null hypothesis, effects or differences in the alternative hypothesis. And p-value can help us to make a decision about the level of confidence. If our t-statistic is bigger than the certain amount, based on the p-value, we can make a decision that our obtained t-stat is significant or not. We already used this table, t-distribution critical value. If our absolute value of the t-stat is bigger than the critical value, that which indicated here, we can make a decision based on this type of the confidence level, our t-stat is significant or not. In this module, we will focus on the statistical storytelling. Storytelling emphasizes on the connection between our statistic and context. For example, when I say that 6 people were killed by shark attack in last year, you cannot say that what does this value say, because you cannot compare with the trend, or you cannot compare with the context. The first concept is the statistical literacy, which is learning and using of quantitative skills within a particular context. In the storytelling, we link between our statistical values and the context, which can be a comparative, which can be a monitoring the trends, or which can be whatever that you are going to apply to figure out the obtained data. So this is the important what and how are variables measured, what technique of analysis or statistical applied to measure the variable, and also how you can interpret the result, which is completely linked to the context that help to understand and reasonable conclusion for the audience. Our next topic is the disconnect between the correlation and causation. If we consider about the relationship between two variables, we need to consider about the type or inherent of the relationship. If it is a correlation, we need to interfere based on the correlation relationship. If it is a causation relationship, we need to interpret based on the causation relationship. So in the correlation, we focus on the size and direction of the relationship. But in the causation model, we focus on the sequence of events. And relationship between two data sets or variables can be a linear or nonlinear relationship. But in the causation, the relationship is a causal. For example, X makes Y. Without X, we cannot predict the Y. But in the correlation, X and Y can change or can impact each other.